Assalamu alaikum. I'm a student of BS Chemistry. In today's video, I'm going to explain what are oxidizing agents, their definition, their chemical transformations, and some of the most commonly used oxidizing agents and their applications plus examples. First of all, we will see what is an oxidizing agent. As we already know that oxidation is the loss of electrons, but an oxidizing agent makes oxidation happen. An oxidizing agent is basically a substance in a redox chemical reaction that gains or accepts an electron from a reducing agent. In other words, you can also say that an oxidizer is any substance that oxidizes another substance. An oxidizing agent is also known as an oxidant, oxidizer, electron recipient, or electron acceptor. In this slide, you can see some of the common examples of oxidizing agents such as metachloroperoxybenzoic acid, pyridinium chlorochromate, hydrogen peroxide, KMnO4, etc. Next, we will discuss about chemical transformations of oxidizing agents. Oxidizing agents are explained on the basis of three main concepts. First, on the basis of gain of electrons. Secondly, they behave as an oxygen transferring species. And thirdly, they remove hydrogen from the other species. So, in the first heading, we will see how they behave as an oxidizing agent by gaining electrons. In the reaction of zinc and copper, copper ion behaves as an oxidizing agent by gaining electrons from zinc. In the next heading, it will tell us about another characteristic of oxidizing agent, mCPBA, that is metachloroperoxybenzoic acid, is behaving as an oxidizing agent in Baeyer-Villiger oxidation reaction, which converts cyclic ketone into cyclic esters that are also known as lactones. In this slide, there is the third characteristic of oxidizing agent, that is removal of hydrogen. In this equation, you can see that bromine acts as an oxidizing agent because it removes hydrogen from hydrogen sulfide and converts hydrogen sulfide into sulfur. Further, we have some examples of commonly used oxidizing agents. Here we have KMnO4, that is potassium permanganate. It is a powerful oxidizing agent and can be used for the oxidation of several organic molecules. The equation explains the oxidation of ketones into carboxylic acids by using KMnO4. Next is potassium dichromate, that is K2Cr2O7. This is a powerful oxidizing agent, especially in an acidic medium. This chemical compound is commonly used to oxidize alcohols. So this equation also explains the oxidation of primary alcohols into carboxylic acids by using K2Cr2O7. Third is mCPBA, that is metachloroperoxybenzoic acid. This oxidizing agent is used in Baeyer-Villiger oxidation, which is the conversion of ketones into esters. Similarly, Prilezahev reaction is also one of the reactions in which mCPBA is used for the conversion of alkenes into epoxides. Prilezahev reaction is also known as Prilezahev epoxidation. Then comes Tollen's reagent. It is an alkaline solution of ammonical silver nitrate. It is a mild oxidizing agent that oxidizes aldehyde groups to their respective acids and it gets reduced. It is a chemical reagent that is used to distinguish between aldehydes and ketones. Next is Jone's oxidation. The Jones oxidation is an organic reaction for the oxidation of primary and secondary alcohols to carboxylic acids and ketones respectively. It is named after its discoverer, Sir Edward Jones. Jones reagent is basically a solution prepared by dissolving chromium trioxide in aqueous sulfuric acid. To effect a Jones oxidation, this acidic mixture is added to an acetone solution of the substrate. Alternatively, potassium dichromate can also be used in the place of chromium trioxide. The oxidation is very rapid and it is quite exothermic reaction. Pyridinium chlorochromate is also another oxidizing reagent. It is a milder version of chromic acid. PCC, that is pyridinium chlorochromate, oxidizes alcohols from primary alcohols to aldehydes and from secondary alcohols to ketones. In contrast to chromic acid, PCC will not oxidize aldehydes to carboxylic acids. Further, we have pyridinium dichromate. Pyridinium dichromate is also known as Cornforth reagent, that is a strong oxidizing reagent which can convert primary and secondary alcohols to aldehydes and ketones respectively. In its chemical structure and functions, it is closely related to other compounds made from hexavalent chromium oxide such as pyridinium chlorochromate and Collins reagent. Further, we have Des-Martin periodinane. Des-Martin periodinane is a widely used reagent for the mild oxidation of alcohols to aldehydes and ketones. The neutral condition of the oxidation reactions make DMP, that is Des-Martin periodinane, a suitable choice in synthesis of sensitive functionally complex intermediates. Next, we will discuss about swern oxidation. The swern oxidation, named after a scientist called Daniel Swern, it is a chemical reaction whereby a primary or secondary alcohol is oxidized to an aldehyde or ketone using oxalyl chloride, dimethyl sulfoxide, DMSO, and an organic base such as trimethylamine. In the last slide, we will see the applications of oxidizing agents. Oxidizing agents have many commercial and industrial applications. They can be used for the bleaching of fabrics as well as for the purification of water. Oxidizing agents can also be used for the combustion of fuels and for the energy storage in batteries. They can also used in the vulcanization of rubber, that is for increasing the elasticity, and they have many applications in biological processes such as metabolism and photosynthesis. That was all about oxidation as well as oxidizing agents, their applications, some of their examples. Thank you very much.